Today, 28th May, we're doing two things. The first thing is just a quick introduction. I'm not going to say a lot about it. We will deal with it when we are doing proofs of it. I do have to mention this now because you might end up using it in the homework. And the first thing we are looking at, and this is the first or a new grade 11 thing, and you are going to use this on a regular basis, is trig identities. Now you have two trig identities, so you need to know this. Basically you need to be able to identify it anywhere you go, right? And the first one is that instead of writing tan theta, you can write tan theta as sine theta over cos theta. Okay, it's basically in your languages you would refer to it as synonyms of each other. So instead of saying tan theta, I can write it as sine theta over cos theta. There's a whole proof in your textbook if you want to go and have a look at it. It is on page 187. I'm not going to go into the proofs as just yet. I'm just telling you, you need to know this. The other one, remember that the other day in your homework exercise I said to you, highlight this. The second one is sine squared theta plus cos squared theta equals 1. That is always true. So if I give you sine squared theta plus cos squared theta, you can immediately go and tell me, well, I can, instead of writing sine squared theta plus cos squared theta, I can immediately go and write down it is 1. Now, because this is also an equation, I can use it differently as well. I can, instead of writing sine squared theta, I can write sine squared theta as 1 minus cos squared theta. That's when I isolate sine squared theta. And when I want to just have cos squared theta, I can take sine squared over and use that. Okay, this we will stumble upon at the end of the chapter, but it's just worth a mention at this part. Right, so we are today going to look at your Cartesian plane, and we've always referred to it as the cos diagram, and we have spoken about all of them are positive. Sine is positive here, cos is positive here, and tan is positive there. But today we are also going to expand it, and we're going to do something called the reduction formula. All right. So as we know that positive angles goes anti-clockwise, so if I had to put my values down for my cos diagram, it will start at 0, anti-clockwise 90, and so forth. Right, so we know that all of my functions are positive in my first quadrant. Okay, the next quadrant known, I know that sine is positive here, but the rest is negative. But this quadrant is also known as the 180 minus theta quadrant. Okay? Meaning, if I had to put in a triangle in here, okay, the angle is labeled from the x-axis and it goes anti-clockwise, and it's called theta. So this little angle inside my triangle is 180 minus theta because its angles on a straight line. All right, so what do I know about angles on a straight line? They give me 180. What do I know about 180 minus theta? So instead of writing sine theta, and I know that all my sine ratios are positive in here, I can also write it as sine 180 minus theta. I'm not going to ask you to do that. I'm rather going to ask you to write sine 180 minus theta as sine theta. Okay, so what happens if I give you cos 180 minus theta? Now, what do I know about cos in this quadrant? I know cos is negative. So 180 minus theta is negative cos theta. And if I do tan, so instead of saying tan theta, I know tan theta in here is negative. So instead of saying tan theta, I'm going to say tan 180 minus theta. And I need to know in 180 minus theta quadrant, tan is negative. Okay, which means if I move to my third quadrant, I know that all my tan functions are positive. If I had to put in a coordinate point there, what do I know? I know that I have gone through 180 and I added a little bit. So this quadrant is also, instead of talking about quadrant 3, I can say I'm talking about quadrant 180 plus theta. Okay. So instead of saying tan theta is positive in here, I can say that tan 180 plus theta is positive here. Now, what do I know about sine and cos? I know that sine is negative in here. I know that cos is negative in here. But I can also refer to it as sine 180 plus theta or cos 180 plus theta. Okay. If I move to my fourth quadrant, I know all my cos values are positive. So if I add an angle and I go through 180 all the way and go through there and I plot my triangle there, I can say, well, okay, it's 270 plus something, but we don't talk about that way. We say, instead of talking about the fourth quadrant, we speak about 360 minus theta, because it's the whole way around is 360, but if I take away theta, because theta is measured from x to there, I have 360 minus theta will give me that little angle there. So what do I know about cos theta here? It's positive. But instead of talking about cos theta, I can also talk about cos 360 minus theta. What do I know about tan? Tan is negative. So what do I, instead of saying minus tan theta, I can say tan 360 minus theta. What do I know about sine in here? Sine is going to be negative, but I can also refer to it as sine 360 minus theta. Okay, so this, in my first quadrant, I know all my values are positive. I know sine theta is positive, I know cos theta is positive, I know tan theta is positive. But what if I say to you, you've got sine of 400? That means I will go a full 360 and I will have to add 40 degrees down there. Okay, so I know that it's normal sine, cos and tan, but they will also refer to the first quadrant as 360 plus theta. So instead of just saying sine theta, I can say sine 360 plus theta. Instead of saying cos theta, I can say cos 360 plus theta, and tan 360 plus theta. Okay, so that is all my reduction formula. So I would suggest to you, you at this point need to know, before I answer anything, the ratios, sine, cos, and tan. I need to know the reciprocals. I need to know the special angles. I need to know the trig identities. And now I need to know my reduction formula. That's all my theory. I suggest you make a little note of it before you answer any of the questions. Okay, you need to know it. What are the questions I'm going to ask you? I'm going to say to you, for instance, write the following as a function value of an acute angle. So sine 145. So I've gone through the 90. In which quadrant do I end up? At the second one. Okay. So what must I write down in theta's place, so 180 minus theta, to end up with an answer of 145? So sine 145 is as good as me saying 180 minus 35. Okay, 180 minus 35 equals 145. Right. So, this 180 minus just indicates the quadrant I am busy with. So, this tells me I am busy in the second quadrant. What do I know about the second quadrant and sine? In the second quadrant and sine is positive, and I only use the 35 degrees. So do it on your calculator. If you put in sine 145, get an answer, and punch in sine 35, you will get exactly the same answer. Okay, so if I say cos 215, so I started at 0, 90, 180, I'm in here. So, how did I get 215? I said 180 plus. Okay, so 180 plus what is 215? It is going to be 35. Now, what is the 180 telling you? In which quadrant I am busy? So 180 is in the third quadrant. What do I know about cos in the third quadrant? In the third quadrant, cos is negative, and I only write the acute angle. Okay, so go take your calculator, punch in cos 215, get an answer. You will get exactly the same answer if you say minus cos 35. So I'll go through it slowly. So how do I get that answer? Find out in which quadrant it has traveled into. Write that 145 using a sum. The first bit of the sum tells me in which quadrant I am in. That tells me whether I've got a plus or a minus, and just use the acute angle. Right. So, what do I do if they say without the use of a calculator? Remember, I said 95% of the time you're going to do this. So I need to be clever about it. So if I do this quickly, I know that's 180 minus theta, that's 180 plus theta, that's 360 minus theta, that's 360 plus theta. I have all sine, tan, and cos. Okay, that is my little, let's call it a crib note. So if I have cos 120, it means if I start at 0, where did I land up? I landed up in the second quadrant. So instead of writing cos 120, write it, how did I get 120? I said 180 minus 60. Right. So what is the 180 telling me? 180 minus, it's telling me I'm in the second quadrant. What do I know about cos in my second quadrant? I know it's a negative. And just use the acute. Now 60 is what? A special angle. So I quickly need another crib note. So I know that's 0 and 2. So that is 1 square root 2 square root 3. And then 0 will be here. So it's 1 square root 2 square root 3. And if I look, that's A and O, A and O, A and O. 60, A is 1, hypotenuse is 2. Right, if I have 225, start at the 0, 90, 80, if I go past that, 270. So 225 is in here. So how did I get 225? I said 180 plus what? 45. What is the 180 plus telling me? The quadrant I'm in. And that is the third one. What do I know about tan in the third quadrant? It's a plus. Use the acute angle. Tan 45. Tan is O over A. So 45, I will have square root 2 over square root 2, which is equal to 1. Sine 315. 90, 180, 270, where do I land up? In the fourth quadrant. The fourth quadrant is 360 minus. So how did I get 315? I subtracted 45. What is the 360 minus telling you? The quadrant I am working in. What do I know about sine in this quadrant? I know sine is negative. Use the acute angle. So minus sine is O over H. So in 45 I have O is square root 2, H is 2. Okay, number D, 300. So 0, 90, 180, 270, I'm in the fourth quadrant. Okay, so sine squared, I have 360 minus, how do I get 300? I subtract 60. Okay, what do I know about 360 minus and sine? Okay, so here's my question to you. What is this saying? This is saying I'm going to have a negative sign in my fourth quadrant, and I'm using the acute angle, but there must be two of them. Okay, so I have minus, sine is O over H, and it's 60. I have square root 3 over 2, that must be squared. A minus and a minus is a plus, Square root 3, square root 3 is 3 over 4. Right, 405. So I'll go full circle. Okay, so 405 minus 360 is going to give me 45. So I said 360 plus 45. Now what is the 360 plus telling me? It's in quadrant 1. What do I know about tan in quadrant 1? It's a plus. Tan 45, so O over H, square root 2 over square root 2, that's equal to 1. Okay, so what do I do if I have 630? I'm just going to move F down here, cos 630. So I can rewrite it saying it's 360 plus, what's it going to be? 70, 270. So 360 plus says to me I'm in quadrant 1, so everything is plus, and 270. Now what do you realize about this? You have to realize that this is referring to my graph. So 90 and 270 are my 0 points, and that is 0. Okay, this is your work then for today, Thursday 28th of May. I hope that you practice this and listen to my instructions. This is new. What do I have to do for Monday? I need to complete my homework, exercise 7.4, and those numbers, and use the memo to mark it.